Hello everyone, today we are going to continue the lesson on steam turbine and major component fundamentals. In this video, we are going to discuss about dummy balance piston, rotor coupling and gland seals of the steam turbine. The design of reaction blading results in a pressure drop across both stationary and rotating blades. This means that a thrust force is applied to the rotor in the direction of steam flow. The most common method to reduce this force is to alternate the flow direction in the different stages HP, IP, LP and to use a dummy or balance piston. The diameter of this piston is calculated as to minimize the force. This force varies with the different operation data, for example plant load output. It is transmitted via the axial bearing to the casing, and from there to the foundation. Coupling flanges have honed bores into which coupling bolts with expansion sleeves are screwed. During operation, torque is transmitted by the fraction force developed in the contacting surfaces. At the same time, the radially pre-tensioned sleeves center the coupling halves so they do not slip, even in cases of electrical disturbances with high transient loads. We differentiate between rigid and flexible couplings. In the case of single-shaft combined cycle power plants, both designs are integrated to adapt to the special need. The generator is located in between the steam and the gas turbine. To be able to separate the turbines into smaller units, for example gas turbine, steam turbine and generator, each rotor is equipped with a coupling. Couplings are introduced to increase the ability for individual overhaul and transport. Coupling flanges have honed bores into which coupling bolts with expansion sleeves are screwed. During operation, torque is transmitted by the shearing force of the bolts and sleeves. At the same time, the radially pre-tensioned sleeves center the coupling halves so they do not slip, even in cases of electrical disturbances with high transient loads. The gas turbine and the generator are one unit and are coupled rigidly with an expansion sleeve coupling. The steam turbine is used only in combination with combined cycle and therefore the coupling is flexible. The design is made in such a way that the steam turbine can be started individually and will be coupled to the generator at nominal speed. On to the next part, we are going to discuss about gland seals of the steam turbine. Stationary and rotating turbine components must be sealed to prevent steam leakages into the atmosphere, air leakages into the LP turbine, maintain the correct and efficient steam flow within the turbine. Since contact-type shaft sealing can cause distortion and deformation of the rotor, sealing segments are designed to be non-contacting during operation, thus limiting friction effects. The seal is built as a labyrinth for the steam which, passing the labyrinth, continuously loses pressure. As it is not possible to absolutely prevent steam from flowing into the seals, a system of different pressure chambers in the seals is necessary. The shaft seal consists of lower and upper parts fastened together by screws, which have elongation shanks and which are centered by tapered pins. Radial slots are inserted in the shaft seal casing for the gland seal exhaust system and for the relief steam system. Via openings, the slots lead into steam passages between the shaft seal casing and the turbine casing. That part of the shaft seal casing lying next to the shaft serves as a segment seal ring. Individual segments of each segment seal ring are led into T-slots in the upper and lower parts of the shaft seal casing and are pressed radially onto the T-slots by means of compression springs. That brings us to the end of the video. In the next video, we will be discussing about steam turbine bearing, main stop valves and control valve of the steam turbine. Thank you for your watching and see you then.